Hello friends. So in the last video we had planned that for GATE 2025 we will have a special preparation for 4 to 5 weeks so that before your examination you are reinforced with the knowledge of geotechnical engineering as well as foundation engineering. This is a highly specialized subject and this doesn't need any cramming. Better understanding of the concept. If you know it conceptually, you can deal with any kind of problem. And that is the requirement of any competitive examination. How you are going to attempt the geotechnical and foundation engineering, what tips will help you in fetching good marks, that should be our impetus. The main focus will be on scoring better marks so that you are ahead of others. So you are in a position to perform better. So from knowledge point of view and from examination point of view, if you divide geotechnical and foundation engineering, from foundation engineering also, which is very, very important part, you have good number of questions from foundation engineering side. If you go through the previous year questions in foundation engineering, you have got 5 different topics, right from subsurface investigation down to the last chapter, that is on deep foundation. And from deep foundation, mainly it is pile foundation. So pile foundation, the axial load carrying capacity of a pile, the group action, the ultimate load carrying capacity of the pile groups, and the uplift load carrying capacity of the pile groups by using a static formula. So that's the deep foundation. And when I was going through the questions of previous years, recent years, I found that deep foundation has been given good importance. So today we will begin with deep foundation. That's an important topic. So deep foundation, in deep foundations, you have got in your syllabus the pile foundation. So what is a pile? Pile, if it is subjected to a axial load, it acts as a cylinder column. So pile is embedded into the ground like this. There is a cylinder column. Why it is cylinder? Called cylinder column. When the pile is embedded into the ground, this column is going to be subjected to compressive force, the axial force. And this is the axial force. This is the force that is being transferred to this pile. So the lateral dimension, if it is a cylinder column, the lateral dimension, which could be diameter of the pile, if it is a circular in cross section, like this. This is embedded into the ground, and you can see the cross section of this pile is going to be a circular one. Then you call it diameter. So D is the lateral dimension. Of the pile. In, say, meter. And if it is circular in cross section, if it is circular in cross section, then d becomes the diameter of the pile. Usually, the piles are going to be circular in cross section, but in one of the paper gate examination, I have seen that the cross section was given. It was a square in cross section. So pile has got the lateral dimension here is going to be, you can say, if it is B, this is also going to be B. So for circular in cross section, we take D as this is the standard notation. D means diameter of the pile. And from the ground level up to the tip, this is the tip of the pile. This length, this depth is called the length of the pile. So L is called length of the pile. Now, if this pile, which is a cylinder column, because it is going to resist the vertical force, if it is made of wood, it is called wooden pile. So, depending upon the material from which this pile has been made, it could be a wooden pile, it could be a RC pile, reinforced concrete pile, it could be made from mild steel, it could be a steel pile. So, depending upon the material and also depending upon the mode of load transfer, you can say the piles are of different types. What could be the mode of load transfer? It's quite simple. You can see that the mode of load transfer, if I draw here the load transfer mechanism, if this is the ultimate load, then the load will be transferred through a skin friction. Like this. So this pile is embedded into the ground, and when I apply the force, this is embedded into the ground, so there is going to be friction at the surface of the pile. So on the surface of the pile, there is going to be unit skin friction. So this part is called the unit skin friction. So this is the basic. This is called unit skin friction. And this standard notation is called Fs. And this is acting over the pile shaft because the pile is embedded into the ground. So when I'm having a vertical force, this is being resisted by the skin friction. So this is resisted this skin friction is resisted at the pile surface. So the surface area can be called, this is the notation, surface area. Now the unit of surface area will be in square meter, and the unit skin friction Fs will be in kilopascal. This is the unit of unit skin friction. So load is the unit skin friction comes on the surface of the pile, and the surface area of the pile we can designate it as a suffix s, as. Now, also the pile tip, when you are applying the axial force, the pile tip will also resist the this force, external force, which is being applied on the pile top, and this is called unit end bearing resistance. Unit end bearing resistance will be also in kilopascal, and the pile tip, its area, if it is circular in cross section, it will be pi by 4 d square. So therefore, the area at the pile tip, area at the pile tip or pile's end, we can designate it as A, and we can designate this unit end bearing resistance by QE. So if you apply the law of statics, the ultimate load carrying capacity of a single pile can be written like this. So let's see. Therefore, we can say that, therefore, we can say, therefore, from law of statics, the ultimate load carrying capacity of a pile QU will be equal to this unit skin friction Fs multiplied by, is going to act over the shaft area. So area of the shaft plus here at the pile's tip or pile's end, it is going to be unit end bearing multiplied by area of the pile at its end. So the unit of QU will be kilonewton, and we can write it QU equal to load transferred through skin friction plus load transferred through end bearing. So this is how you can calculate it. So if you find that the load transferred through a skin friction, QS, is much larger than QE. QE is insignificant. Say it is 10% of the total ultimate capacity of the pie. You can say it is insignificant. 90% contribution comes from load transfer through a skin friction. So QS is naturally much larger. So if you see that QS is much larger than the load transfer through end bearing, then it is called frictional pile or friction pile. And reverse is also true. If you find that QE, or if you find that QS is much less than QE, say this is only 10% of the total. So 90% contribution comes from end bearing. Then the pile will be called end bearing pile. So it depends on the load transfer mechanism when you are applying the vertical axial force over the pile top. The magnitude of the forces being resisted by the pile will decide whether it is a friction pile or it is end bearing pile. So, from a static formula, we are in a position to calculate the ultimate load carrying capacity of a pile. If this is 1, we may call this 1A. Okay. Now, how will you find out this unit skin friction and unit end bearing? It is a function of the ground condition. It will depend upon also the material of the pile, what kind of pile you are going to use it. And it will depend upon what is the properties of the ground. As you know, in geotechnical engineering, the ground could be cohesive or it could be cohesionless. If you go to IS 2911, the codal provision in deep foundation for pile, you will find that the code is crystal clear about these particular aspect of this load calculation of unit end bearing and this. So this Fs and QE are the functions of soil or bed properties, soil properties, or ground properties, soil or ground properties. What is the properties of the ground here? So also it depends upon the pile's material. As you know, it could be a reinforced concrete normally, but it could be mild steel also, it could be wood also. So depending upon this, you can calculate the unit skin friction and unit end bearing. And this another component, that is the shaft area and the area of the pile at its tip. This is the tip of the pile. So what is the area of the pile at its tip? Where are going to be the function of the pile's geometry. So it depends upon pile's geometry. If it is circular in cross section, the shaft area is going to be different, and you can calculate the ultimate load carrying capacity of a pile. So finally, therefore, the ultimate load carrying capacity in kilonewton can be computed. Let's say there is a single pile and you want to calculate the capacity, and you know the ground properties, how to calculate it. So here there is a single pile embedded into the ground. We will try to find out the capacity of a pile, of a single pile, by applying the law of statics. So if you have a single pile, this single pile is embedded into the ground, the axial force. The ultimate load is going to be Fs As plus QE into AE. Now, in order to calculate this Fs, let's say the ground properties, it's cohesive in nature. So you have a cohesive ground. So pure clay, if it is saturated clay, then the cohesive ground will have the properties. You will be knowing the undrained cohesion, Cu, and phi u will be always 0 degree if it is fully saturated in undrained condition. So if it is cohesive ground, you will be given Cu. You will be also knowing the unit weight, total unit weight of the ground, and the value of Fs will depend upon what is the ground properties. So the ground properties here, Fs, will depend upon the adhesion factor alpha multiplied by Cu, where alpha is called adhesion factor. It's a factor, right? So alpha times Cu. Alpha is adhesion factor. So Ca upon Cu, and therefore alpha times Cu is called Ca. So when you are having a pile embedded into the ground, alpha value you can get it from IS-2911, or you can make use of a formula, API formula, which is called American Petroleum Institute has given a formula which is widely used across the globe. So API formula is depending upon the value of Cu, the value of alpha can be found out. So alpha value depends upon 1 minus Cu minus 25 divided by 90. So if value of Cu, the undrained cohesion of the ground, is less than 25, then the value of alpha becomes 1. And if it is more than 70, then the alpha values becomes lesser. You can just calculate it API. Otherwise, in IS-2911, and in the examination, the alpha values are given to you. So you need not bother. And Cu, the ground properties will be given to you. So alpha times Cu you can always calculate, and therefore you know Fs. Then the another value, the shaft area. The shaft area, if it is a circular in cross section, the diameter will be given to you, and length of the pile will be also given to you. Now, under the axial force, this is going to be Fs, unit is skin friction, and into the shaft area will be perimeter of the pile. So perimeter of the pile will be pi into d multiplied by length. So shaft area is also known to you. Now the next term comes QE, that is here how to calculate the unit end bearing resistance. QE will depend upon the ground properties, and the ground is cohesive in nature, and therefore QE will be Cu times Nc, CNC. So for deep foundation, as per IS-2911, the value of Nc is 9. So we can say it is 9 times Cu. So Q is also known to you, and the area at the end can be easily calculated. The area at the end, if it is circular in cross section, it will be pi by 4 ds square. If it is different cross section, let's say the cross section is square in cross section. The pile is no longer circular, it is a square in cross section. Then the shaft area will be perimeter of this. If it is the square pi, a square in cross section, and this lateral dimension is b, then it will be perimeter will be 4 times b multiplied by length of the pile. But if it is circular like this in cross section, like this pane, it is circular, then the dimension is going to be d, then the shaft area is as given over here, pi d, that is the perimeter multiplied by the length, right? So depending upon what is in one of the gate problem paper, I have seen they have changed the cross section of the pile. So in the examination, they can give you different cross section. If this is the cross section, then the area at the end for this one will be how much? You can easily find it out. It will be bs square. If it is circular, it will be pi by 4 ds square. So very easily you can find out the ultimate load carrying capacity of a single pile. But remember, the pile is never used as a single entity. Pile is always going to be used in group. And when the pile is going to be used in group, you should know the group pattern. The minimum number of piles prescribed in the code is going to be 3. So the group action is very, very important here. So this was for a single pile embedded into a cohesive ground. So you have seen how to attempt the problem of single pile capacity embedded into cohesive ground. If it is cohesive in nature, you can easily calculate by using this. You can calculate Fs, you can calculate QE, you can find out the shaft area, etc., etc., substitute in the expression, and you can get the ultimate load carrying capacity of the pile. And if they give you the factor of safety, usually 2.5, as per codal provision, you can find out the allowable load. So allowable load will be the ultimate load carrying capacity of the single pile divided by factor of safety. So you can find out what is the allowable load carrying capacity of a pile. But as I told you, piles are never used as a single entity. So we will go to the group action. So piles are always used in groups. Remember it. Piles are always used in groups. So you must know what is the group pattern. So minimum number of piles is also defined. Minimum number of piles in a group as per codal provision, there is 3. If you are going to have 3 piles, so this is the plan V. These are the piles, and pattern is called triangular pattern. This is called triangular pattern, isn't it? So these are the piles. So if it is going to be a triangular pattern, and if I take a sectional view, how it will look? It will look here. There is going to be one here. This is the pile cap embedded into the ground. This is the ground level, and you can transfer the load. So this is one of the pattern, triangular pattern. The pattern could be a square pattern. So that if there are 4 piles, or it is going to be 9 piles, it is 2 by 2 pattern. 2 by 2, 4 piles, or 3 by 3, you can go for 9 piles. 4 by 4, you can go for 16 piles in a group. 5 by 5, 25 piles. These are called square pattern. If the number of piles, capital N, is going to be, say, other than this, say it is not 4 piles, it is 6 piles. You can have a pattern like this also. This is called rectangular pattern. The pattern could be different. So there are different patterns. But in the examination, mostly you will be asked, I have seen your questions, gate questions. It's going to be a square pattern. And this is embedded into the ground. If you take the problem of any, say, it is a triangular pattern, how will you find it out? Now, these piles are in a group and it's a triangular pattern. So now the piles are going to, under this load, it's going to interact with each other. So this center to center spacing is going to be very important now. The center to center spacing between 2 consecutive piles. So this is called center to center spacing between 2 consecutive piles. So center to center spacing is very important, because under the given load, there is going to be pressure bulb, there is going to be pressure bulb, and these pressure bulbs, if it is very close, will merge. So this ground will be highly stressed where it merges. These are the pressure bulbs. So if it is going to be there, the ultimate load carrying capacity of the pile group, theoretically it should be number of piles into the ultimate load carrying capacity of a single pile. But it is not the case because of the merging of the pressure valves. And therefore, you will have to, this is not always the case. So here, the pile capacity in a group, so how to find out? Therefore, this is not always the case. Therefore, how to find the ultimate load carrying capacity of a pile group. Now we are talking about the group. So now as you are seeing that there is going to be interaction between the pressure bulbs, the center to center spacing is very important. And if you refer the IS code, the center to center spacing is normally given as 3 times the piles diameter, right? So if it is going to be 3 times the piles diameter, now it is being found that the ultimate load carrying capacity of the pile group equal to number of piles in the group and ultimate load carrying capacity of the single pile multiplied by group efficiency factor. So you have to multiply it by group efficiency factor. So wherever you want to find out the ultimate load carrying capacity of the pile group, this is equal to number of piles n into ultimate load carrying capacity of the single pile multiplied by group efficiency factor. This group efficiency factor, therefore, is going to be equal to, this is a factor, and therefore this group efficiency factor, eta G, is called the ultimate load carrying capacity of the pile group divided by number of piles in a group into ultimate load carrying capacity of a single pile, isn't it? And this eta G, the maximum value could be 1, but for that you should have larger spacing, center to center spacing between the piles. There should not be any merger of these pressure bulbs. The pressure bulb is going to merge. It will never be equal to 1. So you will have to see that center to center spacing is going to be quite large. And therefore, the design of the pile cap will be uneconomical. This is the pile cap. So pile cap design becomes uneconomical if the center to center spacing is going to be quite large. So therefore, the code is normally providing this guideline that center to center spacing should be 3 times D. If it is a compaction pile, then you should have closer center to center spacing, because the purpose is going to improve the ground density. And for compaction piles, you keep it 2 times D or 2.5 times D. So there, the motto is different. Otherwise, normally center to center spacing equal to 3 times D. In the examination, center to center spacing will be given to you. It will be always be given to you. If it is not given, you can safely assume it 3 times the pile's diameter. And therefore, the eta G, you can always define it as a factor. This is going to be in kilonewton. This is the number of piles. This is also going to be in kilonewton, so it becomes a factor. This eta G can be also calculated from Feld's rule. This Feld's rule, you can apply it for any type of configuration, whether the group pattern is triangular or square or rectangular or say diamond shape, or it is a circular pattern. And for any pattern, you can make use of this Feld's rule. Let's say for triangular pattern, how will you calculate? So you want to calculate eta G, the group efficiency factor. This is called group efficiency factor equal to, from Feld's rule. Now, how many piles are there here in a triangular pattern? 3. And with adjacent piles, its interaction, say the pile number 1 will have interaction with pile number 2 and pile number 3. So it will have 2 interactions. Similarly, pile number 2 will have interaction with 1 and 3. So it has got 2 interactions. Pile number 3 will have interaction with 1 and 2. So the number of interactions here is going to be 2. Number of interactions is going to be 2 here. So number of piles, you know it, number of piles n in triangular pattern, it is 3. There are 3 piles. So number of piles multiplied by 16 minus number of interactions. Number of interactions. So what is the number of interactions? 2. 1 here, 1 here. So number divided by number of piles into 16. So group efficiency factor for say n equal to 3 will be how much? So therefore, the group efficiency factor for n equal to 3 triangular pattern can be found out eta g equal to number of piles equal to 3. So n equal to 3 into 16 minus number of interactions divided by number of piles into 16. So it becomes 14 divided by 16. So in decimal places, you can always calculate it. So that is the factor. So group efficiency factor from Feld's rule, you can calculate it. If it is a square pattern, let's say the pattern is like this. This pattern is no longer triangular pattern, it's a square pattern. These are the piles, 4 piles. So now number of interactions, say pile number 1 will have interaction with pile number 2, with pile number 3, with pile number 4. So how many interactions? Each pile will have 3 interactions. So number of piles for eta g for this will be number of piles n becomes 4 into 16 minus number of interactions for a square pattern. Here it is 3 for 2 by 2, 4 piles in a group divided by number of piles, that is 4 into 16. So it becomes 13 by 16. So you can calculate for any kind of configuration of the pile groups, whether it is a square or even if it is diamond, you can calculate it. Very easily you can calculate it. There is another formula also that is called Converse-Lebedev formula. So you have got Converse-Lebedev formula to calculate eta g. The group efficiency factor eta g can be calculated by using Converse-Lebedev formula. You will have to remember these formulae. So eta g is given by Converse-Lebedev formula as 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by m into n. So this is the Converse-Lebedev formula, where theta is called tan inverse diameter divided by center to center spacing, d by s. So this is the formula given by Converse-Lebedev. But this Converse-Lebedev formula cannot be used for triangular pattern. It can be used for other pattern like a square, rectangular pattern, you can use it, but you can't use it for triangular pattern. Why? Because here M is called the number of piles in a row. In plan, how many piles are there in a row? It is 2 piles. Then N is called number of piles in a vertical to this or in a column pattern. So if you go perpendicular to this, how many piles? Here it is 1, here it is 1. So you can't make use of the converse Lebedev formula for triangular pattern. So triangular pattern here fails. Triangular pattern group efficiency factor cannot be used, cannot be found out by using converse Lebedev formula. However, for any other pattern, you can use converse Lebedev formula. So it is not universal in nature. Now, say if it is the pattern is like this. Now, the pile pattern is like this. For this, the number of piles M equal to 2 and number of piles in a column also equal to 2. You can now use it here. But here you can't make it for triangular pattern. So converse Lebedev formula fails for triangular pattern. Now, let's say I want to find out the capacity. If it is a triangular pattern, how I should calculate the ultimate load carrying capacity of the pile group. That's very important. So this is the triangular pattern, and you want to find out the ultimate load carrying capacity of the pile group. Let's say the ultimate load carrying capacity of the pile group is QUG. This is the symbol. Now, when the piles are going to be in triangular pattern like this, it is like this, and there is going to be group interaction here. Now, the piles can fail one by one under the ultimate load. So when I am applying the maximum load, the ultimate load on this pile group QUG, the piles can give in. There can be a shear failure. So slip line or the shear line will get developed. Here, one pile has gone. Then progressively, the another pile also fails. Then the third pile fails. So one by one, the pile is going to fail. So this could happen because now the center to center spacing will decide whether it is going to be a individual shear failure or a group shear failure. So based on individual shear failure, there is going to be individual shear failure. The pile is going to fail one after the other. So this is called individual shear failure. Based on this ISF, the value of QUG, if it is a pattern like this, will depend upon the number of piles and into the ultimate load carrying capacity of a single pile multiplied by group efficiency factor. This formula you must use if it is individual shear failure. So in the individual shear failure, the pile is going to fail one by one and the slip line is going to form around the pile. So around the pile, the slip line or the shear line will be formed. So here you can show it like this. This is the slip line. This is the slip line. What do you mean by slip line? There's no contact between this pile and the ground. The pile has failed. When I apply the maximum load, this pile has given in. It has failed in shear. And therefore, there is a gap between the adjoining ground and the pile. And that is shown as a slip line or the shear line. That is called individual shear failure. But sometimes, if your motto is to compact the ground, you are going to have center to center spacing very closer. And when you drive the pile, say in sandy ground, we go for lesser center to center spacing. And when we drive the pile, the soil within the pile here, the soil here will get compacted and its density increases manifold compared to the density outside. So density, it is a densified area. This soil within the pile is going to be densified. Now, when you apply the maximum load, the shear line will develop only at the periphery. This soil will not fail. It will act as if it is a part, monolithic part. So if you have a pile, like this, embedded into the ground, and this soil is going to be not going to fail, no shear lines, then it is going to act as if it is a monolithic unit. It forms as if it is the part of the pile group, and therefore the shear lines will get developed only on the periphery. It will develop. The slip lines will develop here on the periphery. This is called block shear failure or group shear failure. Block shear failure or group shear failure, BSF, or group shear failure. So this can happen. It can happen based on individual shear failure. This is the expression. So if it is a group capacity, you should first calculate the ultimate load carrying capacity of the group, G for group, based on individual shear failure and also based on block shear failure. So how will you calculate it? Let's say it is a triangular pattern. So if it is a triangular pattern, now this slip line will get developed. How it is going to get developed? In block shear failure. In the block shear failure, I've got the piles like this. So my slip line is going to act as a one block. So slip line will be shown here like this in block shear failure. And therefore, the QUG will be, now the skin friction will get developed on the periphery where the slip line is going to form. So the skin friction, the shear force, is going to be only on the periphery because this part is acting as if it is part of the pile itself. So perimeter of the group multiplied by the length of the pile. This is the length of the pile. So perimeter of the group into length of the pile where the skin friction will come into picture. So into Fs plus. Now at the end here, the end bearing resistance will get developed. So plus the where it will get developed, the area of the group multiplied by unit end bearing resistance. This is expression number 2. This is based on block shear failure or group shear failure. So expression number 2 corresponds to group shear failure. Expression number 1, equation number 1 corresponds to individual shear failure. Now you have got two equations. PG is the perimeter of the group. You can easily find out the perimeter of any group pattern. You can find out the area of any group pattern. So you can find out the ultimate load carrying capacity. So out of these two, which will you recommend as the ultimate load carrying capacity of the pile group? You have got two values. From 1 and 2, the minimum value should be recommended. The minimum value of QUG should be recommended as the ultimate load carrying capacity of the pile group. So this is very important point that you should bear in mind. Once you know the ultimate load carrying capacity of the pile group, divided by the factor of safety, if you, as per codal provision, the factor of safety could be 2.5 or 3. You divide it, the ultimate load carrying capacity, by the factor of safety, you will be getting the allowable load the pile group can carry. So my next video will be on problem solving actual gate problem of different patterns. And conceptually also I will do it for a triangular pattern. For different patterns, how to solve the gate problems. So today I am putting break over here, and in the next video I will come up with a real gate problem right from 2024 up to 2015, 10 years, and then down for another 10 years. Like this, I will solve all the problems on pile foundation to find out the capacity of a single pile when subjected to axial load by allowing the law of statics, or to calculating the ultimate load carrying capacity of the pile group. The group could be a square, group could be diamond group could be circular in group pattern, or it could be a triangular pattern. So for different patterns, I will be solving the real life problems and also gate problems. That will drive the point home crystal clear to your mind. You can send me your feedback so that teacher also gets encouraged. Such questions I have set in public service examination also of different states, this triangular pattern and all. And it's asked even in engineering services examination. So in the next video, be prepared with your calculator, everything, and try to solve various gate problems. Thank you very much.